Hey guys, last time we talked about the substitution method, and today we're going to talk about our final method for solving for Algebra 1 students, and that is a method I call the elimination method. And the elimination method takes advantage of a new way of thinking about solving problems, and that is that there are times when you can combine equations together to form new ones. As a quick example, notice I've got two systems of equations here, and I lined them up, x's on top of x's, y's on top of y's, equals on top of equals, numbers on top of numbers. And I'm going to add these up, old school addition style, column by column. So if we add 3x's and 2x's together, we get an equation 5x's. If we add 4y's and 3y's together, we get 7y's. And on the other side, if we add 10 and 12 together, we get 22. That equation, 5x plus 7y equals 22, as well as the other equations, all have the same solution, the same pair of numbers that makes it true. Now this was an example of adding equations that wasn't very useful, but notice what happens when we add these two equations together. 4x plus 3x's, when we add them together, we get 7x's. 2y and minus 2y, when we add those together, they cancel out or are eliminated, hence the name. And on the other side, 100 plus 40 gives us 140. And notice this equation is very easy to solve. Divide both sides quickly by 7, and we've already got half of our answer. That x has to equal 20. Using the substitution method, it takes quite a bit before we get our first number, and with the graphing method, you've got to graph both equations before you find either of the numbers. So, elimination has this potential of being really quick. Now, how did it happen? What makes this equation or system different than this system over here? The key is that there was a pair of terms that were opposites. And if you ever notice that there are opposites in a system, then elimination is a good method to choose. So, the steps for the elimination method, it looks like the most complicated method, but honestly, the first two steps are usually done for you if you're going to choose to do the elimination method. If these first two steps aren't done, then it's probably faster to solve the system using a different method. So anyway, to use the elimination method, the first thing you need to do is make sure that all the variables and equal signs are lined up, just like the examples that we had before. The technical word for this is that you should have your equations written in standard form. And so earlier in the year, when you complained about why do you make me write it in standard form, this is one of those reasons. Second step is to either find an opposite, or if there isn't an opposite in there, we can actually create one by using a multiplication trick. Once you have opposites, then you can move to step 3, which is to add the equations together, and that will eliminate a variable. A lot of students tend to get too carried away and add things up too quickly, and that doesn't accomplish anything if you haven't made an opposite yet. So make sure that step 2 has been done before you proceed to step 3. Then steps 4, 5, and 6 are actually just like the final steps for the substitution method. Once we've got an equation that has one variable in it, you'll solve that equation, you'll make a substitution, and then you'll solve that equation for the other variable. So let's see this elimination method in action. Here's a simple equation, simple system, x plus y equals 10, and 5y minus x equals 26. And we'll solve this by using elimination. The first thing I want to make sure is that everything is lined up. That first equation is in standard form with x's, y's equals numbers. This equation is not. I've got y's and then x's. So I'm going to switch this around. So the negative x I'll write first, and then the 5y. So this equation becomes negative x plus 5y equals 26. If I take the first equation and just kind of transfer it over, x plus y equals 10. Now everything's lined up. X's, y's equals numbers. The next thing I notice is right away I see in the x's column that there are opposites. I've got a positive x and a negative x. So step 2 is done. I can move to the adding step, and x and negative x, they cancel out. My first year of teaching, my students got really into this method, and they often shouted out, "You've been eliminated!" And so if you want to do that same sort of thing, as long as it's not during a quiz, go right ahead. The x's, "You've been eliminated, you're gone." And over here, y and 5y, they combine to give 6y. And 10 and 26 add up to 36. And just like that, dividing quick, we've done step 4 and solved for our first variable. Y has to be a 6. So step 5 now is to take this number and plug it into an equation somewhere and figure out what x is. We actually have kind of 4 different equations we can choose from. We can go back to this equation, or this rewritten equation. Honestly, it won't matter. You could choose any of them, and so I would try to choose the simplest one. I think this x plus y equals 10 is the simplest. Plugging in a 6 for y, you could probably figure out in your head that x would have to equal a 4. So we've got a combination of numbers, a 4 for x, a 6 for y. I already know what makes this top one true. Let's test the bottom one. 5 times 6 is 30. Minus 4 does indeed give us 26. So there's our answer. So here's another example, and this one has a little bit of a twist in the fact that there isn't an opposite. I'm getting ahead of myself. First of all, the x's are on top of each other, the y's are on top of each other, and then the numbers are on top of each other. So step 1's been done. But step 2, I look, the x's, those are not the same number but opposite sign, and the y's are not the same number but opposite sign. And so I need to somehow create an opposite. And the tool that we can use to do that is to take one of the equations and multiply everything in that equation by a number. If we choose the right multiplier, then we can create opposites. So if I look at the x's, and I kind of think back to common denominators sort of thing from adding fractions, if I can make both of these, say, fourths, or both of them have a multiplier of 4, then I'm close. If I can make this somehow be a negative 4x, and this a positive 4x, then I'll have opposites. And the multiplier that would allow that to happen is if I took this top equation and multiplied it by a negative 2. The negative 2 times positive 2 gives me negative 4x's, and that would be the opposite of 4x's, and so on I could add them. So what I usually do is rewrite both equations. This gives me negative 4x's, and negative 2 times y is minus 2y, and negative 2 times 3 is negative 6. If you're thinking you're going to be one of those students that might forget to multiply all these things by negative 2, then feel free to use the distributive property and draw in this arrow. Everything in the equation has to be multiplied. The bottom equation can just be transferred over. No changes have to be made there. And at this point, if I add these equations together, negative 4x and positive 4x gives me, well, they've been eliminated. And here with the y's, negative 2y and positive 3y add up to a single positive y. And negative 6 and negative 15 add up to negative 21. And the solving step's already done. Y is already by itself. And so I've got one of my two numbers. And to find the x value, I'll take this and plug it into an equation somewhere. I think this original one before I multiplied it is probably the easiest one to use. So if you need to, you can rewrite it a little bit lower. 2x, I'll take the y out and replace it with 21. So plus negative 21 has to equal 3. A quick addition gives me 2x equals 24. And dividing both sides by 2, I get an x value of 12. So the combination of 12 and negative 21 is the combination that makes both of these equations true. Now, I chose to multiply both sides by multiply this top equation by -2. I want to show that you could also create opposite y's. If you were to, say, multiply instead by -3, then -3y and +3y would become opposites. Let's quickly look and see what that would give us, see if that would make a difference if we had chosen that route instead. I'll use a different color. So I'll start by just writing the original equation, 2x plus y equals 3. And suppose we chose to multiply everything by -3 instead. Again, everything needs to be multiplied. That gives us -6x's, -3y, and -9. And if I just copy the other equation over, I get 4x plus 3y equals -15. And a quick addition now that I've got opposites in the y's, gives me -2x equals, and on this side, -24. And I hope that equation looks relatively familiar to you. Dividing both sides by -2, and we'll get the same x value that we got earlier, which only goes to show that it doesn't matter if you create opposite x's or if you create opposite y's. The key is just to create an opposite somewhere before you add, and you'll make some progress. So the last example I wanted to show you is an example where it's a little difficult to see what opposite to create. So 3x plus 7y equals 45, and 5x minus 2y equals -7. I notice, first of all, everything's lined up. That's a good thing. Step 1's done. Now I want to try to create opposites, and I don't see any single number that I could multiply the x's by to get them to match but be opposite signs, nor do I see any number that the y's could, unless I was willing to multiply maybe the bottom by 2.5, maybe, but even that I don't. So it's just not as simple as it was before. And here we really need to think about the ideas, same sort of ideas that come with common denominators. If I were to add a third and a fifth together, how would you do that? Well, the only way is to make these both into 15ths. So if we multiply this fraction by 5, we get 5/15. And if we multiply this fraction by 3/3, then we get 3/15. And then we can add it. Notice I took this equation and multiplied it by this number. I took this fraction, and multiplied it by this number, kind of flip-flop those. That same sort of trick can be done with these equations. So if we look at the x's, if I can make both of these 15s, then I'll be close to an opposite. If I can make one of them -15, then I'll have an opposite. And so this trick will always work to create an opposite. If you multiply the bottom or the top equation by this bottom number, and if we multiply the bottom equation by this top number, then you'll get the same number, 15x's and 15x's. What I really want is one of those to be negative, so let's multiply this bottom by a -3 instead of a +3, and I'll have 15x's. And on the bottom equation, -3 times 5x gives me -15x's. There's my opposite. Remember, you also need to multiply everything else in the equation. So 5 times 3 is 15, 5 times 7 is 35y's, and 5 times 45, 5 times 40 is 200, 5 times 5 is 25, so 225. And here, -3 times -2 is +6y. -3 times -7 is +21. And now I'm good to add these equations together. The x's have been eliminated, and the y's haven't. They're 41y. And on this side, 225 and 21 adds up to 246. And if we divide both sides by 41, it does actually divide cleanly. Y is exactly equal to 6. And then we can use this to plug in for a y somewhere. Maybe I'll choose this only because I've got more room to work underneath this equation than the first one. So 5x minus 2 times 6 equals negative 7. So that's 5x minus 12. And adding 12 to both sides, we get that 5x equals, add 12 to both sides. A positive 12 and a negative 7 adds up to 5. And so it looks like x is a nice number, 1. To know for sure if this works, remember you could always test it. Plug a 1 in for x. Everywhere you see a x, plug a 6 in for y. Everywhere you see a y, and it needs to make the equations true. So, if you were curious, I could also have multiplied the y's instead of the x's and created opposite y's. To do that, I would multiply the bottom equation by a 7, and I multiply the top equation by a 2. 2 times 7 is 14. 7 times negative 2 would give me my negative 14, so I don't need to put a negative sign out front here. And then I'd have opposite y's, and the x's would be some other numbers, and when you added those together, you would eventually be able to figure out quickly that x equals 1, and substitute that 1 in somewhere and figure out what y equals. So again, it doesn't matter which variable you create an opposite with. Just try to make the easiest opposite that you can find. So, thanks again for listening. Tune in next time and we will talk about some special sorts of situations that come up where systems of equations don't have answers.